so we're going to be graphing polynomials. This is our last learning target of Chapter 5, learning target 5.4. We're going to be graphing different polynomials, okay? And this is strictly going to be a graphing calculator standard for the most part, okay? You're going to be using that, finding some key properties. I got to teach you how to use the graphing calculator and so on, okay, for a couple different things. But you guys are getting better at it the way it is finding the zeros and everything like that, okay? When you go to graph a polynomial, I would straight out get my graphing calculator, go to y equals, type in that function, okay? So I'm assuming most of you already have that in there, correct? Okay. Now, a couple things that you guys found already. You guys found the zeros, and they were located where?
5, 2, and negative 3.
5, 2, and negative 3. Okay. So those are called the zeros of the function. They would also be where the graph does what?
It's the x-axis.
It's the x-axis. So couldn't I also call them the x-intercepts?
Yeah.
Yes.
Okay. You can also call them the roots, and you can also call them the solutions. They're essentially all the same. Okay. So zeros, roots, solutions, x-intercepts. Okay. Those are all the same thing. Alright, so just so to help you with some terminology there, if you hear me use them interchangeably, it's because I can. They mean the same thing. Okay? On a little side note here, could I write this function in factored form right now? Could I write it in factored form? So something times something times something.
Yeah.
If you know the zeros, can't you write it in factored form? What would our three factors be? X
No, minus 5.
minus 5, yep, has to be minus. X minus 5.
X minus 2.
X minus 2.
X plus 3.
X plus 3. So you could write that polynomial in factored form now that you found the zeros. Does anybody have any questions on that? On that side note there, is everybody good? Paul, are you with us now on that one? Because I know before you were kind of shaking your head, so you're okay now?
Yeah, now I get it.
Once you have the zeros, you can definitely write the factors. Okay? Alright, well, we're going to go ahead and we're going to graph this. Now, I'm going to try and squeeze it in right here just for the purpose of the film, but I already have 3 coordinates right now, don't I? Those 3 coordinates right there. I know those 3 coordinates on the graph, so I'm going to go ahead and draw an x and y axis. You said it hits at 5. It's a 2. And negative 3. Okay? Did anybody get a good picture? Has anybody looked, I guess, at the graph to kind of see what it does? Nick, what does it do? So it kind of comes up, down, and back up like that? Okay?
It barely goes over the x-axis on the first.
Oh, so it just kind of does one of these?
Yeah.
Like that? Probably depends on what your window is, though, too. Okay? If your window is tiny, it might go off your screen, but if your window is huge, it might look like it just barely goes, right? Okay? So you guys are saying, in general, it's going to look like this, correct?
Yeah.
Okay? Every cubic function, x to the third, every cubic function is going to look something like this, or the exact reflection of that, okay, like this. Okay? Every cubic function will look like this. Sometimes the bumps, the hills and the valleys are a little bit smaller, okay? Sometimes they're even just kind of levels out and then goes up like that, okay? But for the most part, you're going to look something like this anytime you have a cubic function, okay? Now, some special points on a cubic or anything to a higher power, okay? This point right here, the very top of that hill, that is called a local maximum. That is called a local maximum. This is something you're going to have to be able to find. you're going to have to be able to find that coordinate where that local maximum occurs. It's called a local maximum because it's not actually the maximum of the graph. Would this graph even have a maximum? Because it goes on up forever, right? Does it have a minimum? No, it goes down forever. But it does have a local maximum. What a local maximum is it's saying, okay, with respect to all the other coordinates or all the other points on the graph that are fairly close to it, this one's the highest up. Okay?
There's a local minimum too.
So, yeah, if you're kind of, yep, absolutely. So if you're kind of looking at all the other points on this graph, so you're looking here, you're looking at all these coordinates right here that are really close to this one, this is definitely the highest one of all those coordinates right there. So it's called a local maximum because locally, nearby, that's the highest point. Okay? And absolutely, take a wild guess as to what's that called. Local minimum. Okay? And you're going to be asked to figure out where those are located. Okay? So first of all, we need to be able to see this whole part of the graph. Okay? We need to be able to see that on our calculator screens. Okay? Now, I haven't done this one yet on my calculator. I'm going to go ahead and do it real quick. You guys are going to have to tell me what it is again when I get my other screen up.
Wouldn't that be the local maximum? So it's like the very high point. So it'd be
Take notes on the different things that I'm going to be showing you and probably try and do them. If you don't have a graphing calculator
it's be 0.9.
on hand, sit next to somebody and watch them use it. Take turns using it. I got a pretty good picture on the...
Yeah.
First step, Mr. A.
Go to y equals, top left corner. Well, you should have this in there already, right? Because you found the zeros. So help me out. What do I have? X to the third.
Minus 4x squared minus 11x.
Hold on. This isn't very fast.
Minus 11x. Plus 30.
Okay, so this is on my standard window right now, okay, guys? This is on my window from negative 10 to 10, negative 10 to 10. A lot of times your calculator is going to start off with that window, okay? You guys understand what I mean when I'm saying negative 10 to 10, negative 10 to 10? It means this x value right here is negative 10, negative 9, negative 8, negative 7, all the way up to positive 10, and then from negative 10 to 10. Basically, this is as big as the little sheets that I print out for you, you know, that you graph by hand. That's how big the screen is right now. What can I not see right now?
The top, the maximum.
The local max and the local min. So I need to be able to see higher, so that means what am I going to have to do to this 10 value right here?
Raise it. Raise it.
Increase it, right? So my y maximum needs to get bigger. And what do I need to do with my y minimum? Get smaller, okay? The way you do that is you press your window button right over here. It's next to y equals, says window. Okay? So you can see, that's what my window is set now. Negative 10 to 10 in the x, so negative 10 to 10 in the x, and negative 10 to 10 in the y. Do I need to mess with my x? Do I need to see further out left and right?
No.
No, so don't. Leave the x's alone. They can stay negative 10 to 10. Because I don't need to see further left or right. But I do need to see lower than negative 10, so I'm going to make my y minimum a lot smaller, and I'll make my y maximum a lot bigger. Okay? So, what's that? You made it 100? Can you, by making it 100, can you see the top and see the bottom clearly then?
Yes.
Okay?
But you can also do that with 38.
She's saying she only went to 30-something and she could still see it. So,
the local
again, there's
maximum
no right or wrong numbers to plug in, but I always say, you know, go big. All right? Because otherwise you'll try, oh, let's try 15. Not big enough. Then you got to go back and try 20, then 25. No, just guess big. Because you got to be able to see the top and you got to be able to see the bottom. Okay?
Go back to your window.
Well, I did 100 first, and then I got the local maximum of it
And did 100.
out of it.
You did. I entered the equation.
And so I just put in 38.
I'm pretty sure I did, because it was different.
So Caleb said 100 works, so I'm going to go ahead and do that. Now I'm going to go back to my graph. How am I doing on time?
You're at 9.
Okay? All right. When I change it to 100, now I can see the local max and the local min. Pretty easy. Okay? Everybody okay with this? Alright. Now, I know my zeros, right? Okay? But let's find the coordinate of my local max and my local min. Here's how we're going to do that. Right above trace it says calculate. Right above trace it says calculate. So I got to go second trace. Three and 4 says minimum and maximum. Pick whichever one you want to do first. Does not matter. I'll do minimum first because it's the first one on the list. So I'm going to select number 3. So I'm going to try and find the minimum. The minimum occurs right here. Okay? Right now it says left bound question mark. Here's my cursor. I'm going to move my cursor a little bit closer to the minimum, but I don't want to go past it. I want to stay left of where that minimum actually occurs. So I'm going to hit the right button. You can move your cursor by hitting left and right. But I'm going to move it just a little bit. Okay, a little bit closer. It really doesn't matter. I mean, you wouldn't have to necessarily. As long as you're left of it, you're fine. So I'm definitely a little bit to the left of where that minimum occurs. So I'm going to press enter right now. Then it'll say right bound question mark. Okay, so now I need to move my cursor a little bit to the right of where that minimum occurs. Just again, make sure you get to the right of it somewhere before you press enter again. And then I'll go back, move it pretty close to about where it occurs, press enter one more time, and it'll give me that minimum value. Alright? So roughly now my minimum, I'm going to write it up here, my minimum occurs at about 3.7, if we go to the nearest tenth, negative 14.8. How are we doing on that?
Mine, I just hit trace and it just went along the line and
I don't know why yours isn't staying on the line.
But you don't know for sure that you're absolutely at the top. I understand you can hit trace and it'll get you and you can trace it to where you think is the top. Okay? But you might not
did
get
trace.
exactly those values.
So you want to do second calculate minimum. Then
Sometimes
here.
you'll understand you're at the top. Sometimes you might be off by tenths, so I'd rather you do this because this is the absolute. Trace is just hopping along the line, okay? And who knows if it might hop past where the
That's your
actual
min.
highest point is.
What?
Do you follow what I'm saying?
Yeah, I guess.
All right, go ahead and go find your maximum then. Go find your maximum. Same way, except select maximum, obviously.
I typed the equation in. It would be right.
Still under 15.
You're at 13.
Yeah, 1 minute to finish this problem, Joey. Ask somebody else maybe.
Yeah, I already found the max.
I'll tell you mine.
So yours is wrong. You already put in your y equals.
What is it?
I'm not telling you because I know your equation is wrong. If you get a maximum.
So it looks like my maximum is located at -1, 36.
Oh, I got it.
Oh, yeah, that's what I got too.
Okay? So now you got your min and your max. Now we're going to be able to go ahead and...
It says error window range.
Okay.
Well, let me change the range.
All right, I'll look at it here in a second. So at this point, I could go back to my graph. Okay? I could plot my minimum and my maximum on here. And then how do you think I'm going to go get some other coordinates?
The XY chart.
Pull them off your table of values on your calculator, okay? So at this point, to finish it, I'm about out of time, okay? I'm going to plot my minimum, plot my maximum, and then I'm going to use some other coordinates straight off my table of values on my graphing calculator to draw my graph, and then you're done. Okay? So we'll finish that here in just a second. Yeah.